So yesterday we went through and we were solving polynomials by factoring. And factoring is a fantastic way to solve polynomials. It really is. It's one of, honestly, the strongest ways to solve a polynomial, but there are some limitations that go with it. So that's where a calculator, a graphing calculator, can come in handy. Now, the graphing calculator will not get us everything that we need, but it will give us a starting point when we've got a problem that is hard to work with. Like the following. Three x to the fourth minus 2x cubed minus 37x squared plus 24x plus 12. Now factoring is still going to be your best bet if you can do it. It's going to give you the most accurate answers, and it's going to be a part of what we do today anyway. But if I look at this and I try to think about finding the zeros, try to think about factoring it. Greatest common factor is 1. Do you know how to factor a quartic? That's what it's called when it's to the power of 4. A quartic polynomial with 5 terms. No. Factoring by grouping works with 4 or more terms, but the problem with that is that you need to break it into 2 halves. Can you break 5 in half nicely? No. So factoring by grouping even won't work for us nicely here. Here is where taking into account the fact that zeros, aka roots, aka solutions, have another name. What's the other name? Nope. Roots, solutions, zeros has to do with the graph. X-intercepts. So, grab a calculator. Turn it on if they haven't done that already. Right, grab a calculator. Then grab it. We're going to look at the graph of the function. So, I got to get into my graphing menu. Where is my graphing menu on my TI? It's not graph. It's y equals. What about my Casio? Main menu, and then on mine it's 5. On some of yours it's going to be 3. It's the one that says graph. Does your calculator have y alone on all of them? Is it y equals? Are these all y's? If not, you're going to have a problem. On the TIs, is your stat plot turned off? Look at the plots up top. Any of them highlighted? Because if they are, you got a problem. Any of them are highlighted. Scroll up. Click enter, turns them on and off. We need them turned off. So as long as those are not highlighted, you're golden on the TI. On the Casio, you don't have to worry about that. Okay. I plug my function in. Where is the variable button on my TI? Right here, next to alpha. What about the Casio? Where is it? Under alpha. Didn't you just say you have a calculator?
Yeah, it's right there.
I thought you had your own personal one. Oh yeah, no, you had one. Never mind. Don't mind me. Okay, so type in your function. 3 x to the power of 4 minus, ooh, don't do like I just did. Make sure you're getting out of the exponent. 2x to the power of the power button.
Where's that on the other one?
2 buttons to the right of alpha. Minus 37 x squared plus 24 x plus 12. Click enter to clarify that you've got your calculator, or you've got your function in there. And then to see my graph on my TI, what do I click? Graph. On my Casio, what do I click? Draw. Now, not all of you are going to see the same thing on your calculator because you got to pay attention to where your calculator zoomed in. On your calculator, if you cannot see something that looks nice, change your zoom. On your TI, go to zoom, and a standard zoom should do. On a Casio, click viewing window and click standard. Exit and then go back to draw. Do you see something that looks something like this on your calculator? Can you see the entire graph? No. Do you need to see the entire graph? Also, no. Here's what we're trying to get from the calculator. So we're trying to use the graphing calculator to give us a 0, to give us something we can work with. We're trying to get the calculator to give us at least one x-intercept that we can clearly see. How many x-intercepts do you see on this calculator? 4. Can you tell exactly where that one's located? No. How about that one? No. How about that one? That one's located at x equals 1. That is our golden ticket. X equals 1 is one of our zeros. Now, we're going to work backwards a little bit. If x equals 1 is one of our zeros, that means one of our factors had to have been something equal to 0 that would solve and give me x equals 1. How do I get x equals 1 to be equal to 0? Minus the 1, and I get x minus 1. X minus 1 must be a factor of my polynomial. Now, if I know one factor of my polynomial, how can I make it where my polynomial only has the pieces that were not that factor left? We've done it already. If you know one of the factors, how can you factor it completely? Let me change my question. If it is a factor, what do you know about it? For example, let's go easier. X squared plus 2x minus 3. I know one of my factors is x plus 3. If this is a factor, that means it breaks down into it nicely. When you're factoring, you're breaking things down using what operation? Think of GCF. You're looking for the biggest thing that does what? That divides. For something to be a factor, it divides nicely out of it. And if it divides nicely out of it, you know it divides nicely out because when you divide it, it gets a remainder of 0. Guess what? If we know this is a factor, we can divide it out of it. We're going to divide this polynomial by the factor we just found. So, essentially, in short, you put it in your calculator, you find an x-intercept, and then you divide by what the factor would be given that x-intercept. So, I'm going to divide. What goes in my little box? Because I can do synthetic division here. Positive 1. Essentially, the actual 0 or x-intercept goes there. What goes across the top? I start by pulling down the 3. And I multiply, add, multiply, add, multiply, add, multiply, add. 1 times 3 is 3. Add and I get 1. 1 times 1 is 1. Add and I get negative 36. 1 times negative 36 is negative 36. Add and I get negative 12. 1 times negative 12 is negative 12. Add and I get 0. What is this polynomial that starts with 3? 3x to what power? 3x cubed plus 1x squared minus 36x minus 12. Is that something we can factor? It's got 4 terms, now we can factor it. When it's got 4 terms, you factor by breaking in halves. You factor by grouping. What's the biggest thing I can divide out of the first half of this? X squared, leaving me with 3x plus 1. What can I factor out of negative 36x and a minus 12? Negative 12. Leaving me with 3x and positive 1. X squared minus 12, 3x plus 1. Can I factor it further? No. Is that the fully factored form? Not of the original, because what factor did I leave off? Don't forget that there was that x minus 1 that we did earlier. This is the fully factored form. It's currently equal to 0 if I'm looking for the zeros. Now this one we actually already had, x equals 1. If I set this equal to 0, 3x plus 1 equals 0, I subtract the 1, 3x equals negative 1. I divide by 3, x is a negative 1/3. I set this one equal to 0. Because that one doesn't factor any further because it's not a perfect square. But how do I solve x squared minus 12 is equal to 0? Add 12. Then square root. When you introduce a square root, you also put what with it? Plus minus. Square root of 12. Can we simplify the square root of 12? Does 12 divide by any perfect squares? 12 is 1 times 12, 2 times 6, and 3 times 4. Are any of those perfect squares? 4 is a perfect square. And it was 3 and 4 getting multiplied together. Simplify the perfect square. The perfect square was the 4. Square root of 4 is 2. Leave the square root of 3 alone. Here are my zeros, my roots, my solutions, my x-intercepts. How many of them are there? 4. 1, 2, 3, and 4. That's 2 solutions in 1. So, this is our process today. Use the calculator to find a 0. Divide it out. Factor it to find the others. Let's try another. X cubed minus 6x squared plus 4x plus 16. Now, I notice there's 4 terms, so my brain would say I could try factoring by grouping, but no matter how I group this, it will not factor. So instead, I go to my calculator. I type my function in. X to the power of 3 minus 6x squared plus 4x plus 16. And I look at my graph. Now I have to find whole numbers here. I cannot do the decimals because I don't know exactly what the decimals are. I can estimate, but is that a real root if it's just an estimation? No. Which x-intercept can you tell exactly where it's located? 4. It's hitting the x-axis at x equals 4. Okay. So if x equals 4 is a root, aka a 0, that means that in the factored form, I could have written it as its own little thing equal to 0. How do I get this equal to 0? Minus the 4. I get x minus 4 equals 0, which is the factor I want. It is the factor I can divide out. Now, if it is a whole number factor, then when I factor it out, I can always, or when I divide it out, I should always be able to do long division. What goes in my little box? Positive 4. Always the opposite of the thing you're dividing by, or in this case, it's the same as the root itself. Going across the top. 1, negative 6, 4, and 16. Make sure you're not missing any zeros. This one doesn't have any zeros to miss, so you're good. Pull down the first term, and in synthetic division, it's multiply then add, then multiply then add, then multiply then add. 4 times 1? 4. Negative 6 plus 4? Negative 2. 4 times negative 2? Negative 8. 4 plus negative 8? Negative 4. 4 times negative 4? Negative 16. 16 plus negative 16 is 0. My remainder is 0. Is it a shock that my remainder is 0? No, it should not be a shock that your remainder is 0. What if your remainder is not 0? Something's wrong. Either your root wasn't a root or you divided incorrectly. What is this polynomial? 1x to what power? Squared, because this was cubed. When you divide, it's always 1 smaller when you're doing synthetic. minus 2x minus 4. And now I go to solve that. If I go to solve this, if I go to factor it, I'm looking for two things that multiply to negative 4 but add to negative 2. Do those exist? Multiplies to negative 4 would be like 4 and 1, one of them being negative either way, or adding to 3 or negative 3. 2 and negative 2 adds to 0. Doesn't factor. What's another way to solve a quadratic equation? Completing the square. Quadratic formula. Square roots if that you can do it. Can we do this one by square roots? No. It's got both x squareds and x's. So if I'm trying to solve this, this is the full factor. The full factored form is this. I can't factor that further. So I'm trying to solve, so I set it equal to 0, which is what I was essentially going for, and I try to solve a different way, like quadratic formula. Quadratic formula starts with negative b. Plus or minus what? Square root. Inside the square root is b squared minus 4 ac all over 2a. What's a? 1. What's b? Negative 2. What's c? Negative 4. So, negative 2, plus or minus the square root of negative 2 in parentheses squared, minus 4 times 1 times negative 4, all over 2 times 1. Negative 2 is 2. Plus or minus square root. Do the stuff inside the square root without the square root. And the denominator is 2 times 1, which is 2. What do you get for the stuff inside the square root? 20. Twenty is not a perfect square, but can we simplify the square root of 20? Yes. If you're not sure, think about your factors. 1 times 20, 2 times 10, 4 times 5. Are any of them perfect squares? 4, which means it's square root of 4, square root of 5. Simplifying the square root of 4, we get 2. Can we simplify the fraction? As long as all of these whole numbers divide by something, we do that. They all divide by 2. 2 divided by 2 is 1. Plus 2 divided by 2 is 1. Square root of 5. Technically over 2, but do I need the over 2? Sorry, over 1. Over 1. Over 1. Don't mind me. Do I need over 1? No. Do I technically need that one? No. Do I need that one? Yes. That is 1 plus or minus something. I don't need 1 in front of things. I don't need 1 dividing things. If you have all of the ones, it's not wrong. So, my roots, my zeros, my x-intercepts are x equal to 1 plus or minus the square root of 5, as well as x equal to 4. Got one more example for y'all. Put the phone away. When solving, your best option is factoring if at all possible. Can we factor this one? Is there a greatest common factor we could do at least? You could factor out an x. Leaves me with x cubed minus 14x squared plus 57x minus 66. If I was trying to factor it further, I would factor by grouping. There is nothing that those numbers are going to have in common enough in order for factoring by grouping to work. So I go to my calculator. Now when I type in my calculator, I can type in the original. It's going to give me x equals 0 as one of its solutions. Or, if I prefer, I can look at the graph of this one, this other factor that I have. And it's not going to give me the 0, but it will give me the factor in common that these have. Are the graphs going to look the same? Absolutely not. But both of them should have the same x-intercepts with the exception of this x. So it doesn't matter which one you type in. In fact, I'm going to type in each of them. To make my point. In fact, it would have been better yet, still, if I had put them into the same calculator. Red graph and the blue graph, clearly not the same. But are they hitting this x-axis at the same points with the exception of the 0?
Yeah.
So, that's the key thing. You could type either one of them in. Any roots that you see clearly on the two of them? X equals 2. What am I doing with that root? Sorry, I can't hear you. I think. Did you say synthetic or subtractive? Synthetic. Yeah, we're going to do some synthetic division. Now, in all technicality, I don't actually need the factored form for this one. But if it helps you see the factored form to plug what goes in here, do that. The factored form would have this equal to 0. It's x minus 2. If that helps you know that the number you plug in here is 2, then go ahead and do that. Otherwise, you can always plug in the root. Just keep in mind, you plug in the opposite of the factor or the same as this. I don't want you getting those mixed up. I recommend you divide this one by that factor. If you do that one, you can do it, but when you're going to factor it out, it's going to make you factor out the x later. So you might as well go to this one. 1, negative 14, 57, 66. Bring down the first one. Good catch, negative 66, thank you. 2 times 1 is 2, add, and we get negative 12. 2 times negative 12 is negative 24. My brain has shut down. When I add these two, what do I get? 33. 2 times 33 is 66. Add them, and I get 0. X squared minus 12x plus 33 is another factor of mine. If I'm trying to solve, I'm setting that equal to 0. I have one solution. I have one solution. I need my other 2 solutions. Can I factor this? I could try, but are there 2 things that multiply to 33 and add to negative 12? No. Can I use square roots? No, there's regular x's. Quadratic formula? Negative. B is negative 12, so negative 12 plus or minus the square root of b, negative 12 squared minus 4 times a. What's a? 1. Far too often people are telling me a is x squared. A, b, and c do not have variables. 1. C is 33. All over 2 times 1. 12 plus or minus an ugly square root. All over 2. I believe you should get 8. Can anyone verify? Do we get 8?
I got 12.
You got 12? I can do it wrong. That wouldn't shock me all that much. Yeah, I get 12. My bad. Can we simplify the square root of 12? You could simplify it if it divides by any perfect squares. If you don't know if it divides by any perfect squares, start looking at all the factors. 1 times 12, 2 times 6, and 3 times 4. Are any of them perfect squares? Still 4. So it's square root of 4 and square root of 3. And the square root of 4 simplifies to a 2. Last but not least, can I simplify the fraction? Yes. 12, 2, and 2 all divide by 2. I get 6, 1, and 1, and I don't need the divide by 1, nor do I need the 1 in front of the square root of 3. Those are not like terms, they do not combine. How many solutions do I have on this one? How many roots? How many zeros? 4. 2 right here, the 0 from when we factored out the x, and the 2 that we got off the calculator. So, Working with bigger polynomials requires a lot of looking at that calculator to kind of help us out. As I mentioned yesterday, we're back on page 188. This time it's day 2. Problem numbers 19, 20, and then 33 through 38.